Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is conditional compilation. Before proceeding, make sure that you have already watched these other videos first. Conditional compilation is often a form of project configuration. Imagine that you usually build your software for running on Windows, and this code works just fine for you. But then you get some new customers who demand your software also works on Linux. You wish to keep using your existing code without needing to start over on a parallel code base that you'd have to maintain just for the sake of building on Linux. But there's this annoying function that you're using. It works fine with your Windows compiler, but not with your Linux compiler. So what to do? Let's assume for now that your Linux build would be okay if only that troublemaking function call wasn't there. In that case, you can wrap that problematic portion of source code within preprocessor directives. Normally, you're building on Windows and this code will compile exactly the same as our original code. But when your new customers request a Linux build, all you need to do is remove this preprocessor symbol definition, which will cause the preprocessor to skip the code between ifdef and endif. The compiler proceeds as if that portion of code had never even been typed. In fact, you might even have some code that is the other way around, code intended for when you are building on Linux, which you want to skip on Windows builds. A popular usage of conditional compilation is to protect against a programmer accidentally including the same header file multiple times. By wrapping the header file's entire content within these guards, that content is certain to be compiled the first time it is included, but not any subsequent times. But the preprocessor has its limits. In particular, it is unable to reason about data types. Consider this admittedly contrived example. We have two different functions, one accepting an int parameter and one accepting a string. We have two more accept either functions, which merely delegate to the first two functions. Now, let's try to consolidate the two accept either functions into one templated function. We want to conditionally only use accept int for one specialization and only use accept string for another specialization. This mysterious conditioning actually has an easy solution. There's a template traits feature that gives us the true or false value we need. But that was the easy part. The hard part is that this code still will not compile. We need to pay attention to the fact that some things happen at compile time while other things happen later at runtime. At compile time, wherever this template is specialized, both the if branch and the else branch both need to successfully compile. Then later at runtime, the if condition gets evaluated and one of the branches is actually used. But the specialization for if cannot successfully compile this call to accept string, and the specialization for string cannot successfully compile this call to accept int. What we need is conditional compilation, where one or the other of accept int or accept string is not even compiled. But we can't use the preprocessor because it knows nothing about a template parameter's specialization. C++ 17 provides us with this solution. Now don't be confused by this constexpr keyword. This is not a compile time constant. Unfortunately, C++ has reused the same constexpr keyword for multiple purposes. In this case, if constexpr creates compile time conditional compilation, only the if branch or the else branch will get compiled into the executable software. A normal traditional if condition often contains things like expressions with variables. It can do so because that traditional if condition is evaluated at runtime. But this conditional compilation needs to be able to make its decision at compile time. That seriously limits what you can put in a conditional compilation's condition. Fortunately, template traits can be completely resolved at compile time, so they are often used for this purpose.